Hello students, I'm Reena. Welcome to Math Fam. Do you wonder how do we solve these kind of probability question? Because you will see in probability Venn diagram based question, there will be tree diagram based question, then you see the conditional probability. So today we are going to discuss how do we solve these kind of question because this topic is very scoring. See, there will be weighted 6 to 10 marks, right? So let us see here how do we solve these kind of questions because this is very easy to score. So let us start with probability. So whenever we talk about probability, you are learning in lower grades also. Probability is nothing but chance or likelihood of any event. If you want to take it here, if I take here probability in the theory, it always chance. We are guessing how can we guess that event, what is going to be the outcomes, right? So here whenever you take the probability always lies between 0 and 1, lies between here 0 and 1, right? Then here, see here, 0, it can be 0, the minimum value can be 0, maximum value can be 1. Now whenever it's a 0 means these are called impossible event. Now if I say here, what is the probability that the sun rises from west? You know that that is impossible event. That's why you will say the probability is 0. But if I say what are the chances of a rain happening, then you will say 50-50%, right? So that means its probability is going to be half. 50% is half. So always your probability is going to lie between 0 and 1, and 1 we take it for the certain event, right? 100% chance of happening. Like if I say sun rises from east, that what is going to be, that is an event, and there is 100% chance that the sun rises from east. So in such cases you will have probability as 1. We can never have probability in negative value. We can never have probability more than 1 also. So this part you have to remember. After that, in lower grades you must have learned experimental probability whenever we are doing any experiments. So here what are the different experiments? You do it here to find out the probability. You talk about the tossing a coin here, a coin or two coins or three coins, right? Or you can take it as rolling a die, right? That is also an experiment that you do it. Or what is the other thing? You take it here. If you are having a color wheel also, you will find out which color the arrow is going to fall on which, right? So all these are the experiment because you are experimenting and finding the probability. That's why these are called experimental probability. Then you must have learned how do we find out for these, what is the probability formula. If I am writing here probability of an event, that is always taken as number of favorable outcomes. If I'm taking, all these are the basic that you must have learned in your lower grades also. Number of favorable outcomes divided by total number of possible outcomes. So this is the basic formula we use to total number of possible outcomes. Right. So here if I'm taking here, because we are talking about outcomes, then what should we know? We are going to list the outcomes, right? So if I do list the outcomes, if we are listing outcomes, that's called sample space. See, you should be aware of all these terms related to probability. So experiment is there. This is the way to write on. P of E means probability of an event. P represents probability and E represents event, right? So whenever we list, because we are talking about here outcomes, so whenever we list outcomes, we call it as sample space, right? Now, if I say what are the experiment and how do we list the outcomes? So here list the outcomes. How do we list the outcomes? Now, if I am taking some example here, the first example, if I say toss a coin. Now, whenever you toss a coin, your possible outcomes are nothing but heads and tails. So, how do we write down here sample space? Sample space is going to be either it is going to be heads or tails. So, this is the way in curly bracket we write down the sample space. Now, if I take here the second example here, if it is rolling a die, rolling a die. That means you are taking a die. So what is going to be, what are the possible outcomes for a fair coin? Okay, fair coin or fair die. Here sometime the word you will see fair. Okay, fair means it is the standard. There, no one has done any kind of changes in that standard die or coin. So, what is the sample space? Whenever I roll a die, I can get either one, then comma, two, three, four, five, or six. So, these are the possible outcomes whenever you are rolling a die. Now, what happened? This is easy because whenever there is possible outcomes can be written in a line, then you can use here sample space and you can do it in the curly bracket. But what happened here, this is called grid method. This is all we are talking about, the different ways to take the sample space. Now the second one is going to be here grid method. Where do we use grid method? If I'm tossing two coins, right? So there is more than one coin you are taking here. Or if I'm taking here two dice together, right? So the way we represent, that's called two-dimensional grid here. So here your grid is going to be two-dimensional grid, which is nothing but when you are taking any two coins, there you take 2 coins or two dice. So how do we do it here? Because it's a two-dimensional grid means I can draw here x-axis, y-axis, right? Now what do we do? In on x-axis you take the possible outcome. So if I take, if this is the example for tossing two coins simultaneously or one by one. So one coin outcomes I'll write on here, which is heads and tails. Another coin outcomes I'll write on here, that is also heads and tails. So this is nothing but the x-axis is representing coin 1, y-axis is representing here coin 2. Now grid means if I take here grids, if I'm taking like this, then wherever these the both horizontal and vertical grids intersect, those are called the outcome. So what is going to be this? You can take it here. We always take here x comma y. So what is going to be the sample space if you are taking here? What are the possible outcomes? What is going to be the possible outcome? It is going to be heads. Then here head tails. So we always take row and then height. So head tails. Then second one at second place it's a tails heads and then it is tail tails. So what are the possible outcomes? If I'm listing here, it is going to be the 4 possible outcomes. So total number of possible outcomes is represented in the sample space. Now grid method is going to be very important. I can take it here in example. You can take here two dice together, or what is going to be the outcomes if I take one coin and one die. Right, you can see that because here you don't need to write on the sample space. By reading grids also you can consider the possible outcomes and the way you are going to find out the probability. Now here what is going to be this here, if I draw here x-axis first and here if it is x-axis and then here y-axis. Now either you can take here coin on x-axis or die on x-axis. If I'm taking here die on x-axis and here one coin, you can change the space also. Now mark all the possible outcome when you roll one die. It is 1 here, 2 here, 3, 4, 5 and 6. And when you toss a coin, your possible outcomes are heads and tails, right? This is tails. Now, what is going to be the possible outcomes if I'm taking here? This is tails. Then again, you need to make the grid here, right here. This is the horizontal. Then what are going to be the vertical grids here? This is this. And you can mark it here wherever both the grids are intersecting, that place is going to be called here. This is C1 and heads, then 1 and tail, then 2 and heads, 2 tails, 3 heads, 3 tails, 4 heads, 4 tails, right? Then 1 5 and then 1 tails, 5 heads, 5 tails, 6 heads, 6 tails. So these are going to be the possible outcomes. How many possible outcomes here? You can see here 12 possible outcomes. You can count here. The intersection is going to give you here total 12 here possible outcomes. So the grid method helps us to find out the sample space when there is more than one, when there are two, right? So this is the second method. First one is just listing it. Now what is the third method? It happens sometime when we talk about, if I'm doing it here, if I toss three coins together, right? So what will happen out three coins one by one? Then listing, you can't, it will be difficult to do this method, listing method or grid, because we can take only two, we cannot use. So there is a third method which comes, that's called tree method. Tree method to represent first all the sample space. Now what is the first experiment? If I take it here, first example here, tossing three coins, right? So here tossing three coins means what are going to be the, we will learn about the probability also using tree diagram. First I am telling you how to use tree diagram to represent the possible outcomes, right? So then we will see how to calculate the probability using these methods. So what is going to be the first one? Because these are called the tree method branches, you are taking the first coin. So what are the possible outcomes here? Heads and tails. Then from each one, because the first coin has already been tossed, then the second coin also, because you are taking here now second coin, again the possible outcomes are heads, tails. Here also, if the first coin is having heads and the second coin can be heads or tails. Now similarly here, if I take the third coin, the possible outcomes are going to be same. So from each one you will get head, tails. Now here it's a head, tails. This is also head, tails. Then here, from here also head, tails. Now how do we read the possible outcomes from tree method? Now first, right? Then first coin heads, second coins heads, third coin tails. So how do we write down here? You can write down, initially you can write down all the possible outcomes next to it also. These are the possible branches. So what is the possible outcomes when all the three coins are having heads? This is your heads, right? So that's why tree method is very important for any kind of complex questions. It's give you sample space very quickly, and it's very easy to identify, then find out the probability. So this is heads, tails. Now I am taking here heads in the first coin, then tails in the second coin. So what is going to be in this branch? Heads, tails, heads. Then here you will have heads, tails, tails. So now if you will see, my this branch is over, because see 1, 2, 3, 4. Right? So all these four possible outcomes are there when we are taking here in the first branch. Then start in the second branch, again there will be four possible outcomes. What are the four possible outcomes? If you will see here, it's starting with tails, then heads and heads. So it is tail, heads, heads. Then the second one is tail, heads, tails. Then the third one is tails, tails, heads. And the fourth one is tails, tails, tails. Now from here, because you are learning about the probability formula remains same. It says the possible, your favorable outcomes divided by total number of possible outcomes. So if you will see here, total possible outcomes, you read this possible outcomes when you are tossing three coins together, or when you are doing one by one simultaneously also. So you can see that possible outcome 1, 2, 3, 4, 5, 6, 7, 8. Right? So here you can write down here 8 is the total possible outcomes. Now let us see how to find out the probability. Now if I say what is the probability of an event getting 3 heads, you can see that out of 8, because my formula is number of favorable outcomes. So my favorable outcomes are it is getting 3 heads, and you can see there is only one possibility of getting 3 heads, so it is going to be 1 out of 8. What is the probability of getting here 2 heads? Exactly 2 heads. You can see that here 2 heads are in this one. 2 heads, it can be in any position. They did not say that in which position head should be there, but they are just saying in the possible outcome there has to be 2 heads. So here you see 2 heads, Then this is also is having two heads. So two possible outcomes, 1, 2, 3. So there are three possibilities where you are having only two heads. They can sometimes mention here only two heads also, right? So only two heads, how many possibility? There are three. This is there, 1, 2, 3. So this is the way we use here tree diagram to find out the probability. Other than here listing method, grid method, tree method, you will see the Venn diagram to represent the data. Use Venn diagram to represent data also, right? Represent data, or sometimes they use tabular form that you see in the conditional probability. Generally tabular form will be there to represent the data. So if I toss a coin, what are the possible outcomes? I know that sample space is heads or tails. So what is the simple question that comes here? How do we write down probability of getting an event which is nothing but getting a head? So you know that number of favorable outcomes, that is only one, which is heads, out of two possible outcomes. Because here if you will see what are the number of possible outcomes here, total possible outcomes here, it is 2, right? So total possible outcomes, it is 2, so it is going to be 1 out of 2. Similarly, if it is probability of getting a tail, it is also 1 by 2. Now sometimes the probability is written in percent also, because here if I am writing 0 to 1, 0 means 0% and 1 means it's going to be 100%. Then you can write down here in decimal also. So here you can take it in fraction or decimal or percentage. So this is also 50%, this is also 50%. Now what happens if I say you roll a die? Because we are going to reach to a new rule that we use for the probability. If I do here rolling a die. Now rolling a die, you know that the possible outcomes are 1, 2, here it is 3, then 4, then 5 and 6. Now what do we say here? What is the probability of getting 5? Right? So probability getting 5 is an event. What is my favorite event? Favorable event, it's 5. So that is, and total possible outcomes are here 6 possible outcomes. So it is going to be 1 out of 6. What is the probability of getting a prime number? So if you will see, out of 6 numbers, 2, 3, 5 are the prime numbers, which is 3 out of 6. And if you are writing in the fractional form, it must be written in the simplest form, so that is going to be half. Now what is the formula? If you know that, what will happen if I am writing here what is going to be the probability of not 5? These are called complementary events. See? So if here 5 is an event, getting 5 is an event, then not 5, not getting 5 is called, it's another event. So 5 and not 5, they are complement to each other, so they are known as complementary events, right? 5, so how do we write on here? Not 5, this is going to be complementary of getting 5, right? So complementary event. So how do we take it here? Not 5. What is the possibility of not 5? So other than 5, you can get 1, 2, 3, 4 or 6. So that is going to be 5 out of 6. Now here you derive one rule here whenever there are two events, right? So if I say E and an event not E, generally it's written as E dash, it's known as complementary event of E. 5 is complementary event of, so here getting 5. Now there is one rule, if you remember, if I am taking here as a note, you have to remember, if I am taking, because and a complement an event, and if I add its complementary event, you always get 1. This rule is very important, you must remember. That means if I need to find out, this is written, complementary event can be written as not E also, P not E or E dash. So this is going to be 1 minus this. So here when I am writing here not 5, because I am having here 1 by 6. So P not 5, I can, using that formula, I can write on 1 by 1 minus 1 by 6, which is 5 5 by 6. So either you take this or this, it's going to be both the same. So we can use this formula to find out the complementary event. Whenever one event is given, what is going to be the probability of the complementary event, right? So here if you will see E as an event, E dash is the complementary event of E, then probability of an event and not happening of that event, it's always add up to 1. Now you will see in probability the AND rule is very important, because see, your first theorem is going to be AND rule, that you need to remember, that you use to you use this rule to solve the question. It says, what is written here, A and P are two events, then happening of A and B, that means as well as event B, we always take the product of their probabilities. So P of A and B, you always take here P, probability of an event A times probability of event B. Sometimes this AND, because AND means it's common elements in both A and B. So we can write down as A intersection B also, which is taken as probability of an event A times probability of event B. Right? How are we going to use this? I'll let you know. Now, other than that, you have to remember this is your theorem 2, which is called OR rule. Now, OR rule will always taken as happening of A or B. Like if I'm telling you here, you are tossing 2 points together. So what is going to be the probability here? One heads and one tail. It can be here HT, or you can get TH. In both the cases, you are getting one head, one tail, and here also one tail, one head when you are tossing 2 coins. So how do we use these two rules to solve the question? Let us see here. It's given here example. It says Joe has probability 3/4 of hitting a target, and Annie has probability 4/5 of targeting the target, right? Hitting the target. Now, if they both fire simultaneously at the target or one by one, the outcomes are going to be the same. What is going to be the probability that they both hit? That means if I take here hit, they both hit means first hit by Joe and second hit also by Annie. Now here you can see this is nothing but it is AND rule. So what is going to be probability? They both hit, so it can be written here as HH also, and you are going to multiply the probability 3/4 by 4/5. Answer you are getting 3 by 5 or 0.6. This is going to be the probability. Now it's written they both miss. That means not hit. How do we write down? We have learned the complementary event. Then it's hit means and they are missing H complement and this. Or it can be not hit by Joe and not hit by Annie. So again, they both and rule is there. So we can take here both miss the target, right? So both miss also, because it's an and rule. You are going to take here what is going to be they both miss, because targeting the probability is given. Now you know that here probability of an event happening and not E is always 1. Now I am having the probability of hitting the target. So missing the target by Zo, you can get it here as 1 minus 3 by 4, which is going to be 1 by 4. And similarly, this is for Joe, right? Now for Annie, if I take it, she is hitting the target with probability 1 by 5. So missing the target, it is going to be here 1 minus 4 by 5, which is 1 by 5. That's why I was telling you this rule is also very important. Whatever rule I'm telling you, you need to remember. It will be helpful to solve the question. Now they both miss the target means not hit and not hit. Again, there is an and rule. That means you need to multiply their probability. So 4 by 5 times 1 by 5, it is going to be 1 by 20, right? So you are getting here probability as 1 by 20. Now here, because the probabilities are given, so directly I have written both hit, both miss. Otherwise, most of the time you draw the tree diagram and you solve these kind of question. Now if you will see here the same question, I have added another part here. What is written here? Joe has probability hitting the target. The same thing. We have solved part A and part B. Now only one among both hit the target. So in this case, maybe Joe can hit the target or Annie can hit the target. That means your AND rule is also coming. So let us first draw the tree diagram to understand how do we take it here. Now, other than that, whenever we draw here tree diagram, you need to write down the probability on the branches. So the first one, if I'm talking about Joe here, Joe is hitting the target. What is the probability? You write down on the branch, which is going to be 3/4. That means missing, not hitting the target, not H you can write down, or M also you can write down. It is going to be 1 minus 3/4, which is 1/4. Now the second target here, the second time it is done by here Anne. So the second event is here targeting by Annie here. So she can also hit the target or not hit the target. Similarly here also you will get here hit the target, not hit the target. And what is the probability? It's given here, it's given here 4 by 5. So 1 minus 4 by 5, it will be 1 by 5. Now here also it is going to be 4 by 5 and this is 1 by 5. Now what does this mean? If you see, most of the time you multiply the probabilities what is given in the target. Now you have to understand here first, this means hit and hit, right? Then here if you will see hit and not hit. Then here not hit and hit are the outcomes, and here they both did not hit the target, right? So see, you can see that and rule is there. That is why when we are writing here probability of both hitting the target, we multiply this. So here you have, I have done here directly, right? And here I'm using tree diagram to get the probability. So they both hitting target, you can multiply the probabilities, because here also if you see the outcome, this is and rule, right? And we have to multiply. So this is again, it is nothing but 3 by 5, same as above. Now probability of hitting by Joe and not hitting by Anne. So you can write down this, but this means and only, right? So it is going to be, again you are going to, if you see, it's going like this and like this. So here what are the probabilities on the branch? 3 by 4 times 1 by 5, that is going to be 3 by 20. Now again probability of not hitting by Aljo and hitting by Annie, if you will see, so I'll be going like this, not hitting and then hitting. So not hitting, what is the probability? If you will see, 1 by 4, and hitting is 4 by 5, that is 1 by 5. And here probability of both not hitting, this first one and Annie, Joe and Annie both, it is going to be 1 by 4 times 1 by 5, which is 1 by 20. You can see this, right? Now after that, if you will see, I have written in the simplest form, but if I write down directly here 12 by 20 plus, and here 4 by 20, which is 1 by 20, if you take total in this, whenever you are adding the probability, right, what are we going to do it here? You are going to take here total. If you take 12 by 20 plus 3 by 20 plus 4 by 20 plus 1 by 20, you will see that you are always going to get total probability as 1. Now how are we going to say? We have seen that how do we use AND rule in when you are using the tree diagram. Now OR rule says, like, first we have used AND rule for solving A and B bit. Then here it says only one among both hit the target. Now one among both hit the target means here only one hit the target, right? Only one person hit the target. Now how to get the probability of this? Now there is a possibility Anne hit and Anne hit and Joe miss, or Joe hit and the Anne miss the target. Joe is hitting and Anne is missing, or Joe is missing and Anne is hitting. So you know that in our rule, you always add the probability. Here, look at here, we have seen our rule. We need to add the probabilities of each case, right? So here, what are you going to do it here? So when I am finding the probability, because it is going to be H dash, or rule, you are going to add probability of H dash H. And we already in the tree diagram having these probability, which is going to be 3 by 20 plus here 4 by 20, that is going to be 7 by 20. So this is going to be the probability that only one person hit the target. So in your question, you can use and or rule together also based on given question. Right now, after that, look at here, what you will see the next part as with and without replacement. Now, till now you were seeing every event was independent event. So, what is the meaning of independent event? That means the outcome of first event does not impact the outcome of the second event. So, let us see how do we draw the tree diagram with and without replacement. Because once you draw the correct tree diagram, it's very easy to identify or find out the probability. So, what is given here? Suppose we have a large group of objects, and if we select one of the object at random, inspect it and its particular feature, then this process is known as sampling. If if the object is put back in the group before an object is chosen again, then we call it as sampling with replacement, because whatever you are taking out, you are putting it back. Like if I'm having a bag full of balls, right? If this is the bag full of balls, if there are three red balls, like in the next example also it's given here, two blue balls and one yellow ball. If I have to pick two balls. Now what can be the case here? I'm picking any one ball out of these six balls and I'm putting it back. That means it will be sampling with replacement. But if I'm taking the first ball, any ball, and then without replacing it, I'm picking the second ball, then it is going to be the sampling without replacement. Then here, look at here. Now, first thing you should know, how do we draw the tree diagram based on this, correct? Now, so first one, we'll draw two tree diagrams. First one is going to be with replacement. So with replacement, if I write down, this becomes independent event, because the outcome of the first event will not impact the outcome of the second event, right? So this becomes independent events, right? And with replacement, when I'll do it here, without replacement, if I'll do it, replacement, that will become dependent event, because the first outcome, you're not putting it back, right? Dependent event, right? Here, because the first, whenever you are taking out any ball, you're not putting it back. So number of balls will change. So that's why it is called dependent event. The first outcome will decide the number of second outcome. So how do we do it here? Let us see. Now we have to take here, what is written here? A box contains here three red balls, then two blue balls and one yellow marbles, right? Instead of balls, they have given marble. Find the probability of getting two different colors when you are picking two balls, right? So box contain when you are picking two marbles. So first, that means there are two events, first and second, to pick the different color marble. So what is going to be here? First one, if I take here, how many different colors are there? There are three possibilities. So I am going to write down like here three. First one is red. This is going to be your here first pick, right? First pick of marble. So you may choose red color marble, blue color marble, or yellow color marble. And probability you must write down on branches. So it is going to be 3 out of 6. Then here it is 2 out of 6, and here 1 out of 6. You can find out here total number of marbles always, and then you can do it. Now I have to pick the second marble. What will happen again? It can be red, it can be blue, it can be yellow. From, if the first is blue, then again you can have three possibility. Here also there can be three possibilities. So this is red, blue, yellow. Then this is also red, blue, yellow. Once you learn this, how to make tree diagram, calculating probability will become very easy. Now, because what happens, you picked first marble and you put it back. So, total number of marbles here will always remain here 6, correct? Then here also you are placing it back. So, there is no change in number of marbles in the bag. So, probabilities also will remain here same. It is 3 by 6. This is 2 by 6. This is 1 by 6, right? And here also 3 by 6, 2 by 6, 1 by 6. This also 3 by 6, 2 by 6, and then here it is 1 by everything. We will see the probability later on. First, let us draw the second tree diagram also where it is without replacement. Now again without replacement also you will your first pick. This one was your second pick of marble. Okay. So here first pick is red. Here also it is going to be the three possibility red, blue and yellow. This is your first pick. Now first pick there is no change. It is going to be 3 by 6. Then the second will have 2 by 6 and third one will have 1 by 6. Again you can have three possibilities here. What can be the three possibilities? Red, blue, yellow. Here also red, blue, yellow. Here also red, blue, yellow, right? You can write down red, blue, yellow. This also red, blue, yellow. This also red, blue and yellow. Now because you have taken the first pick, this is your second pick, right? You may get this. Now what will happen because you have picked first marble and you did not place it back. So in the second pick, your total will reduce by 1. Right now here you have to understand how to write down the probability carefully. Now if I choose first marble as red marble, so total number of marble will reduce by 1, which is 5. Now because your first pick was red marble, then your number of marbles also will reduce to 2. So choosing the second marble as red will be, the probability is going to be 2 by 5. Now first pick was red, so there won't be any change in blue number of blue marble, which will remain 2, but the total has become 5. Right here in the first pick total was 6. Then here yellow also first pick was red, so there is no change in yellow marble, so it is 1 by 5. So this is the way without replacement. Most of the time in real life application you will get the questions based on without replacement only. Then after that if you will see what is going to be, if your first pick was blue ball, again there was no red ball, so total number of red ball will be 3. So it is total will change to 5 and red ball is going to remain 3. Now first pick was yellow blue, so now blue will reduce to 1, total will reduce to 5. There is no change in yellow, yellow will remain 1 by 5 also. So if you see denominator is reduced to 5 because first marble has taken out and it kept it aside. Now the first, if it was yellow, there is no change in red, so red will be 3 by 5. Blue is going to be, there's no pick in the first marble as blue, so blue also remains 2 by 5. Now what happens here, because I picked first marble as yellow marble and there was only one yellow marble. So this becomes here, you cannot pick yellow marble again in the second case. So because we cannot have, it is now 0. 0 means you are going to have 0 as the probability, or you will write down here we cannot have here, this is 0 by 5 because 1 will reduce to 0. That means you cannot have yellow and yellow, can't have this possibility, right? Because there was only one yellow. If there was two, then it will reduce to 1. So that's why this probability is going to be 0. What is going to be probability? Because this is the outcome is y and y, right? Yellow and yellow. So yellow and yellow probability is going to be 0 because it is impossible even. When there are no yellow balls, you cannot pick this, right? Now, how do we calculate the probability here? So we have drawn the two with replacement and without replacement, the tree diagram. Now how do we use this to calculate the probability? Let me give you the cases. Now what is going to be here in both the cases we'll see. Okay, so here if I am telling you here, what is the probability of getting two blue, and here what is the probability of getting blue and blue marble. you will see just the branch here. What is given in the branch here? Blue and this one is red. You will take here the branches because you need here blue and blue, right? This is the case here, blue and blue. So the probability and rule, you have to multiply 2 by 6 times 2 by 6, which is going to be 4 by 36, which is 1 by 9. But here if you will see blue and blue, because it's without replacement, the probability will change. It is 1 by 5, that is going to be 2 by 30, which is 1 by 50. So this is the way you use with and without replacement probability tree diagram to calculate the probability. Now, what are the other type of question, because where it will be helpful, which kind of questions you have to solve it here. I'll give you the another case in this one. I'll give you a few more questions here where you have to use the probability where there are two different colors, right? Here, because here in my question also it was given here, getting two different colors with replacement, without replacement. I have taken the same color. What is the, now what can be the probability getting same color? You can find out here as getting same colors. Now, if I'm taking here same colors, the same thing here, same colors, what will happen? It can be here red and red, or blue and blue, or yellow and yellow, right? This is the possibility. Then here, that means or rule you are going to add. So we can write down here P of R plus probability of getting both blues plus probability of getting both yellows. So we are using and all rule together. Now what is the probability with replacement here? 3 by 6 times 3 by 6, which is going to be here 9 by 36, plus both the blues we have already calculated as 4 by 36, plus both the yellows, because it is without with replacement, it is 1 by 36, right? That is going to be here 14 by 36, and you can get the simplest form. Then here also, if I'm getting both the same colors, it will be P of red, or means you are going to add here both can be blue or both can be yellow, you are going to add, but the probability is going to be different because here outcomes are different. Now it is 2 by 6 times 2 by 5, right? So 3 by 6 times 2 by 5, plus blue we have already calculated as 2 by 6 times 1 by 5, which is 2 by 30, plus now you will see here yellow cannot happen, so 1 by 6 into 0 by 5, or you can skip this step, either you write down 0 by 5 or you can skip. So it's a 6 by 30 plus 3 by 30, which is 9 by 30, and if you'll get it here, and the simplest form will be 0.3. Here also you can get it as 7 by 18, and you can get the decimal value. Now what happens here? But the question says both should be of different color. Different color means both the marble cannot be same color. So what is can be the possibility? Red and blue, then red and yellow, then here blue and yellow, then it can be blue and yellow, right? The same outcome will be there for the with replacement, without replacement in both yellow and red, then it can be yellow and blue, then this is yellow and yellow, which we cannot take it. If it is not same in color, if both the marbles are not in same color, then it will be different in color. So what is the probability here? Both marbles are of different colors. Different colors. I can use here the formula of an event and not an event is 1, because same color we got it as 7 by 18. So not same in color, we can do here not same in color, I can do 1 minus 14 by 36, or 7 by here I can do here 7 by 18 also. So if you do this, how much you are going to get it here? 22 by 36, 22 by 36, which is 11 by 18. Or what is the other? This is the very easy way. Or what I can do here, I can take the probability, because all these cases, or what is the other way to do it here? You can add the probability of red yellow plus probability of red blue, right? Here red blue also you can take it here. This one also you can take it here. 1 2 3 4 5 6, because out of this is red and red, I forgot to write on here. There's going to be how much we can take it here. If we are taking here, it can be red yellow, it can be red blue, or probability of what is there here. What is the case here? Red blue, red yellow, then blue is your blue red, correct? Blue red, blue yellow. So you can take it here, probability of blue red plus probability of blue yellow. Then you can take here yellow red. Now probability can be yellow and red. Then add probability of yellow blue. Then yellow yellow, it is going to be same thing. Now just place the probability, same thing will happen here, and you can get the probability. Or I have used here this rule, and directly we can reach to the probability part. Now other than that, you should know how do we use the Venn diagram to calculate the probability. Now many at times you will see the probability is based on given based on Venn diagram, right? So because it is integrated with your sets topic. So first thing you should know, they'll give you the Venn diagram and you need to mark the correct values there. So how do we use it? Because first you should, whenever you are taking Venn diagram, you should know A intersection B. This is nothing but A and B. Now, the moment you see this, the probability, you know that if I'm writing the probability, you will follow the product rule. So, PA times P and PB, right? Of A or P of B, you are going to add it. That means you need to replace this as plus. So, these two rules you will use here, and sometime Venn diagram you use it for the conditional probability also. Now let us first, you should know how to mark the values correctly in your Venn diagram. So let us first draw it. What is given here? In a class of 30 students, 19 plays sports, right? Here 8 plays music and 3 plays both sports and music. Now first thing I have to define here, if I take S as sports, right? Number of students here, sports students, number of sports students, we can take it as capital S. And music means I can take here, first you have to define whatever you are taking, but generally they give you Venn diagram and directly you can use it. Now here these are the music students, right? Music students. Now what are the total here? Your universal set, the total number of elements, if you'll see, there are total altogether 30 students. Now here what is going to be then n of s, if I'm taking a number of elements, number of students in total sports, this is 19 total, and number of students in music, it is 8. Now it's written they play sports and music. That means if I draw here Venn diagram, here if I take two circles, which is because there are and rule you can use here, the students who are playing both the music and sports part of both, that will become in the common part, right? Now how are you going to mark it here? This is your universal set. Now if I say this part, right, this part and this part together, it has to be 19. Now what students do mistake there, they write down 19 here. That's wrong, because this part and this part together, this whole circle number of sports should be 19. Similarly, the music can't be 8 written here, because this part is only for only music. This part is only sports. But this is the common part which is going to be played. The students who are in sports as well as music. So that is why in that case we take here sports, number of students which are in sports, intersection music. That means here sports and music. So first you are going to mark that part here, which is what is given here. It's given 3, right? So first thing you are going to mark 3 students which are part of both sports and music. Now all together it has to be 19, right? So 3 of them are already there. So remaining will be 19 minus 3, that you must write down here 16. This part you should not go wrong, because if you put wrong values in your Venn diagram, your whole probability question will be wrong. Then here number of students in altogether in whole this circle it is 8, 3 of them are here, so only 5 will be left. Now you add here, which is nothing but what is going to be the number of S union M, the total, the students which are part of both, which is 16 plus 3 plus 5, and 16 plus 8 is going to be 24. Now there were 30 students, so 24 are part of sports or music here. So remaining is going to be here, not so S union M, that is going to both not in this. That is going to be 30 minus 24, which is 6, that you write on outside. Now your Venn diagram is already you have marked all the values in your Venn diagram. Now let us see what is written here. Display the information on Venn diagram and calculate the probability. Now what is given here, if you take the first one, part A, if I take it, they play both sports and music. Now again your and rule will come here. So this is nothing but probability of S and M. You take it the common, which is nothing but it's an intersection. And rule means this is part of common between both. That is going to be 3 out of 30. That is 1 by 10, right? Then what is the second part here? B part. What do we need to calculate here? At least one of sports and music, right? That means all together. So you can write down here, play at least one sport and music. So what is the possibility? It can be one sport, it can be the students can be part of only sports or only music, or they are part of both, right? Now you can see that here there is a or rule, that means you need to add. So the only sport is 16, they play both is 3, and only music is 5. This is nothing but your union, right? Or rule means you will take it as a union. In Venn diagram you have learned that. So probability of at least one means they can play both also, right? So at least here, at least what is written here, one, at least one of sport and music, at least one of sport and music, right? So at least means it will be greater than equals to one event. So it is going to be how much altogether here? It is 19, it's a 24, 24 by 30, 4 by 5. Correct? So this is the way you are calculating this. Now what is there in the third part here? They play sports but not music, right? So here they play probability, play sports, not music, right? That means it is going to be there are some students who are playing both, you can't consider, because if they are in music we should not take it. So only sports are going to be 16 out of 30, which will be here 8 by 15, right? And you can get the decimal value also. Then after that here, what is the next case? Exactly one of sport and music, right? So exactly one means they can have only one sport. One here, they can hear what is given here, exactly one of sports and music. So what is going to be the probability here? It is only sport or only music. See, if you are understanding the question here, it says exactly one of, they can't play both. So you are not going to, we are not going to consider the students who are not part of both, but any one, it is going to be 16 or 5. So that means you are going to add the probabilities here. So I can here I can add here probability of only sports, because there is a and or rule, so you need to add it. Probability of only music. Now only sport was 16 by 30 plus only music. If I see only music, it is 5 by 30. 5 by 30, which is 21 by 30, which is 7 by 10, which is 0.7. Now what is the next probability? If you do one question this, you will get all different types of question here. Now it's written neither sports nor music. That means student is not part of both the events, right? He doesn't play sport, he doesn't play music. So there are 6 students who are not part of any of the these two events. So here what is going to be this here? S union. See, I'm just writing this so you understand what are you will understand the Venn diagram also. So you can directly also write down 6 by 30, which is 1 by 5, right? If you're not writing here, you can just write down in words also. Play neither, right? If you are not able to get this, you can write down here play neither. Then it is 1 by 5. Then what is the last part here? What is written here? Music if it is known that the student plays sport. So the one who are playing both, right? Here, what is here? Here there will be conditional probability also. Now we have not discussed conditional probability, but let us see in whatever is given, how to choose out of that. Now it's written the students, one students from music, right? If it is known that the students play sports, so your what is the given condition? You need to choose the student. So your out of won't be a total student won't be 30, because what is the given condition here? You need to choose the student who is part of sport. Now for the sport, what is going to be a denominator here altogether? It is 19, and out of 19, how many of them are there for music here, who are part of music also? It is 3, so it will become here 3 by 19. Now this comes as conditional probability that we will see in the our next video. So condition, they have given the condition, you need to choose. It plays a student who plays music, but they have to play out of sports also, right? So it is going to be here the next part. If I'm getting here probability that the student plays music, if it is here plays music, what is given here? If it is known, if he knows to play sport, right? Then it is only 3 out of 19. So this is the way you calculate the probability. Now in conditional probability, you will see that whenever there are two events A and B, right? Now this means, if you will see, it's always written like here, if I'm writing here B vertical line A or A vertical line by B, what do we call it as here? This means here the A occurs knowing that B has already happened. So whatever the right side value is there, that means this B has already, even B has already happened, and now here A occurs. So here when I am writing this, we need to find out here probability of happening of A, when we know that given that, you will most of the time you will see the word given that B has already happened, B has occurred, right? Or if I'm writing here B, probability of happening of B event B, when we know that A has already occurred or A has happened. This is called conditional probability when one condition is given here. So if I need to take it here, see, look at here in mathematical notation here, happening probability of B when A has occurred means occurring, B is occurring given that condition A has occurred, the probability of B given A, right? So you'll see that word given that. Now labeling, how are you going to do it? Now if there is probability of A will be there and this is not A, correct? This is A, not A. Now what happened if I'm taking the second event as B? Now you know that A has already happened. So it is going to be A intersection B. Now not happening of B, because happening and not happening of B, when A has already happened, we are going to take it as A intersection B dash. Then here this means nothing but AB. This is your AB dash, because this is AND rule. So AND rule, you know that we take it as intersection. Intersection P of A intersection B is going to be probability of A times probability of B, or you can write down as A and B also, the same rule applies. They have just written in the form of intersection. Now here probability of happening of B, when you know that it is not A, so A dash intersection B, and this one you have already learned in the tree diagram. Now other than that, you need to remember the formula whenever we are having conditional probability be axiom. We should know probability of B when we know A has occurred. It's always taken as A intersection B by probability of A, because now your outcome is not going to be the same. It is going to be probability of A or whatever possible outcomes are there in A. We'll see how do we use this conditional probability to solve the question. Or if they are independent events here, then sometime they'll tell you, see, first theorem you have learned as multiplication rule, where it is intersection, you multiply A and B. Then you have learned the second theorem as OR rule, where happening of A or B will be, you will add their probabilities. Then you sometime you get it here, check if A and B are independent events. You need to check here conditional probability. If probability of happening B when A has happened, A has occurred, is equals to probability of B when not A has happened, then they both the probabilities are equal. That will be equal to probability of B. Then they are independent event. That means one outcome is not impacting the other outcome. So that's the way to check whether they are independent event or not. Now, this is your exam type question, which is based on Venn diagram. It's written there are 24 students in a class. Of these students, 15 plays guitar, and G is written for guitar. Then 12 plays drum, 4 plays neither, and 4 they have marked outside because they don't play any of these instruments. Determine the missing value in the Venn diagram. Now you know that first you will always take the common part here. We don't have common part, right? There are two circle here. How many missing values do you see here? There are 3 missing values, A, B and C, and B represents the intersection part. That means the students who play guitar as well as drums, right? So how do we find out this? You can, because what is the first A part? We need to find out the missing values. So what can we do it here? You can frame the equation and you can solve it. Now I know that 4 of them are not there. So what is going to be A plus B plus C? If I take 24 minus 4, that means these 3 parts blank will add up, should add up to 20. This is your first equation. Now in the second equation, if you will see, A plus B, because 15 students play guitar, right? So that means part of A plus B, that is 15. Now if you have A plus B and the third one B plus C, you can get it as, because there are 12 students who are going to play drums. Now please do not write down here 15, here 12, because what will happen, this is already adding up to 31, which is not right. That's the common mistake part. So always get it here. You know that A plus B together it is 15. So in the first equation, if I substitute here 15 plus C is 20, I can get C as here 5, right? So I can mark here there are 5 students who are playing only drum, because this part is for only. Then similarly in the first equation, if I substitute B plus C, that is going to be 12, which is 20. So A, you will get it as 8 students. So the students who plays only guitar, this is only guitar, you can see that there are only 8. Now just you add 8 plus 5, that is 13, and altogether it was 20. So how many of them are there, students are there who play both? Because in the first equation, now I can substitute A and C to get the intersection part. So that is going to be here, there are 7 students. So 7 students who play both the instrument, and 8 only guitar, 5 only drum. So here 2. Now here if you will see in 1B part, what is given in part 1B, you can see that here a student is selected at random, given that the student plays at least one musical instrument. Now given that means here when it's written here, you know that this is nothing but conditional probability, right? Now if we are having here conditional probability, then you know that what is given here, given that student plays at least one musical instrument, right? So given that at least one musical instrument means how many total students are there here? What do we need to find out? Determine the probability that the musical instrument is guitar, right? Determine the probability that the musical instrument is guitar. So you can take it here, probability of getting choosing a student who plays guitar, given that it's written here at least one music. So anything here, play any, here we can take at least one musical instrument means play instrument, any of the instrument. Now we know that here playing here any instrument, you know that this is going to be G intersection I by here probability of playing any instrument. Now what is here, if I take here G intersection I means playing guitar out of playing any of the instrument. So playing instrument means these two circles are possible. So if I take only guitar is, what is that? 15. So I can take it in numerator as 15 by total. If I take it here, now you need to choose out of the one who are playing only instrument. So if you want to take it in a probability form, then I can take 15 by 24. 15 by 24 by playing instrument is nothing but 20 by 24. This 24 gets cancelled and you will be left with 24 by 20, which is 3/4. Or what you can do, you can remember this directly as you just take the intersection of these two. So playing guitar out of all the instrument, it is 15, and you need to choose out of the students who are playing any of the instrument, which is going to be nothing but 20. That is also directly, because always the total number of students, whatever is here, it will get cancelled. So directly also you can write on 3/4. So this is your based on conditional probability. Now the next question, it says that three students are selected at random. Determine the probability that the three students play at least one musical instrument. Now you have to choose one by one, right? Now here any three you can choose out of altogether. Play at least one musical instrument means there are 20 students who are playing at least one, either only guitar or both or drum. So I can choose from 20 students. So choosing the first student, whenever we are taking here any instrument, right? The first instrument and second instrument and third instrument. So how do we take it here? If I am taking here, the first student out of 20 will be 20 out of 24. Now you have already chosen the first student. So this is going to be without replacement. In actual life scenario, once you have chosen one student, you can't place it back, right? You can't put it back. So it should not be with replacement. It is going to be without replacement. So it is 20 by 24. Now one student went, already it has chosen. So the second student, there are 19 students who plays any of the instrument, and the total also will reduce it to this, because this is AND rule, that's why I'm multiplying. And the third student, now there are only 13, so you can choose any one out of 13, then out of here will become total students 22. So remember this, and then you can multiply, you can write down 20 into 19 into 18. If I'm writing here, it is 6840 by, if I'm taking 24 times 23 times 22, you will get it as 12,140 4, right? And you can take it as decimal also. If I'm taking as decimal, I'm getting here approximately 3 decimal, 3 significant figure 563, right? So this is the probability. Your probability is always going to be less than 1. That you need to remember. So this is the way. Let us go for the next question. Now this is another your probability based question, which is based on tree diagram, and it is carrying here 9 marks. So how do we do it? First you have to fill the missing values. What is written? A bag contains 10 dark chocolates and then 15 white chocolates, right? 3 chocolates are selected at random from the bag and not replaced. So this question is without replacement. Now without replacement, your denominator and outcomes are going to be, total number of outcome will change. Now here first case is, here D dark chocolate and W represents white chocolate. So it's given here 10 by 25, 15 by 25, and if you take it together, there are 25 by 25, which is probability is 1. So this is your first chocolate when you are taking out the first chocolate, right? Now here the second chocolate, because the first chocolate was dark, there's no change in white chocolate, so it will remain here 15 by 24 also. Or if you are writing here 5 by 8 also, it will be accepted. But it's better if you are writing with the same denominator. So it's easy to compare. Now the second one here, we need to find out here the first draw was white and the second draw is also white. Now first draw was white, so it was 15 by 24. Now the total number of chocolate reduced to 24, and because the first you have taken white chocolate out, so it will become here 14 by 24. So your first column, it is done. This is for the second chocolate draw, right? What are going to be the total outcomes? So you are just doing here sample space. Now this is for the third chocolate draw. What is going to be the missing probability? Now see 10, 9, 8. Then what will happen? First chocolate was dark chocolate, then white chocolate, and here first this, if you'll see, this W is the branch is like this here, correct? This is there. So first one was dark chocolate, second one was also dark chocolate, so there is no change in white chocolate. It's still it will remain 15 only. Now what will happen? The first was dark, second was white, the third is white, right? So here if you will see, white chocolate was 15 in the second row, so it will reduce to 14, and total also will reduce to 23. In the third one, denominator of everything is going to be 23. Now what is the missing value? Now first draw is white, second draw was dark chocolate, third is also white. Now white 15, it will become here 14, right? Then after that, the last one here, first one was white, second one was right. So now there will be 13 white chocolates. So you have first fill all the missing value. Now what you need to write down, whenever you don't get it, you can write down here the probability of possibility here. What is the possible outcomes here? All three chocolates are dark chocolate. Then here dark white. This is going to be dark white dark, right? You just see the branch and write down here. Then this is your dark white. Then this is going to be your white dark and dark. Then here this part is white dark white, and this is white dark, and the last one is going to be white, right? So how many possibilities if you will see here? There are, these are the possible combination of white and dark chocolate. Now what is it? And find the probability that exactly two dark chocolates are selected. So out of three, there has to be two dark chocolates. So what is going to be the possibility? You look at the outcomes here. There has to be two dark, and so there were three chocolates. Out of that, two should be dark. So first one, all three dark are there. So exactly two dark means this can be DDW, this combination, or you can have here DWD, dark white dark, or you can have here two dark white dark, or that's it. There are only three these possibilities. So probability of dark white plus, because all rule you have to add it, probability of dark white dark plus here probability of white dark, and you just need to multiply the probability of the branches. So for this case, what is going to be the product? 10 by 25 times here, the second one is also, it will become 9 by 24 times, now white there is no change, so it's a 15 by 23. You will see the denominator is going to remain the same. Then plus dark white dark, so the first dark, without making this tree diagram also, see white white dark, so first one dark is 10 by 25, then white is 15 by 24, then 9 by 23, right? Then plus, what is the third possibility where there are two dark chocolates? So the first one is white, so it is 15 by 25 is the probability, first one. Then dark, which is 10 by 24 times 9 by 23. Now if you will add everything, you are going to get the probability of getting two dark chocolates, exactly two out of these three chocolates. So let us take it here. It is going to be 19 to 15, which is going to be here 1350 plus if I take here 13 nines are 135, 1350 plus if you again take it here 135, 1350, because here it's the same thing, probability it is same, then here 25 times 24 times 23, if you are taking it you are going to get it here by 13,800, and if I take the sum 4,050 divided by 13,800, you can write down your answer in the three significant figure also, so which is your probability is approximately 293. Yeah, the first part is done. Let us go for the second part. Now, this is the next part of the question which says that what do I need to find out here? We found first here out of three when there are exactly two of them are dark chocolates, right? Now, here you can write down one more thing. I can write down in the simplest form because when we are using these values, we can take the fractional value to get the more accurate value instead of estimated decimal value. Now, what is given in the third part here? Let A be the event that first selected chocolate is white. That means my first chocolate is white here, and then B be the event exactly two dark chocolates are selected. That means what is going to be there? First one is going to be white, so this case is true, right? So this is first is white and the other two is exactly dark chocolate. Now here, because it's a given that the first one, what is given here, first there is a condition, it's a given, and here if you will see this symbol, this is also for the conditional probability. This means probability of A intersection B by probability of B, right? Now what does this mean here? A intersection B means here you know that A intersection, the first event is white, right? So it can be written as white, then intersection with dark and dark, so that means or white and dark and dark. So again here you can find out as intersection. So what is going to be the probability? You have to multiply these three branches values because that is representing the probability. So what can I write down here? What is going to be the probability of A intersection B, or the first chocolate to be white and the second chocolate to be dark and dark chocolate? The first chocolate, it is 15 by 25 times second chocolate to be dark chocolate is 20 by 10 by here, now 24 times the third chocolate is dark chocolate, then 9 by 23. Now in the denominator, if you will take the probability of getting exactly two dark chocolates out of 3, we already got it in the second part, which is 27 by 92. Now simplify the numerator, you will get it as 1 by 92, right? So numerator is coming 9 by 92, 27 by 92. So if you take the fractional value, your answer is going to be more accurate. So this is going to be 1 by 3, which is, if you take it in decimal, 3 significant figure, it will be 0.333. And after that, what is the last bit? Now in this part, we have to show that event A and B are not independent. Now if you remember, you have learned one rule here. If A and B are independent, the theorem 1 that you have learned, right? If both the events are independent, then probability of A intersection B should be equals to probability of A times probability of B. If we can prove that they are not equal, then it will not be independent, right? So what do we need to find out first here? P of A times P of B. Now what is the probability of A? A is the event where the first selected chocolate is white. Now look at here, what is the first one selected? This is the probability, the first selected chocolate is white. So what is the probability? 15 by 25. So I'll write on here 15 by 25 times the probability of B. The B was the event which says that the event that exactly two chocolates are selected here, right? Two dark chocolates are selected, and if there are two dark chocolates means it can be DDW, it can be DWD, it can be white, dark and dark also. And we have already calculated here also probability in part B, which is 27 by 92. So here I can write on here 27 by 92, which is from B, right? Now, if you take the product here, you need to take the product and its simplest form, so which is 0.176, and the fractional value of this is going to be 81 by 460, right? So this one you must show it. Now let us take here PA intersection B. Now what is A intersection B here? Again the event here, A is selecting one white ball, one white chocolate, right? So here I need to find out here white. Intersection means it's going to be AND rule. Then here B is selecting exactly two dark chocolates, so D and D. Now you know that WDD, if you are taking the probability, it is going to be 15 by 20. This branch, if you see, white and then dark and then dark. So this is nothing but 15 by 25 times dark chocolate, it is 10 by 24 times 9 by 23. And when you do this part also you have done it in the previous bit. It was coming it as 9 by 92. Now 9 by 92, what will be the approximately here decimal value here? It is coming it as approximately 0.098. Now if you will see from both the values, 0.176 is not equals to 0.098, or you can write down here 81 by 460 is not equals to 9 by 92, right? So therefore we reach to the conclusion A intersection B, it is not equals to the product of each of its probability. Now if this is not true, you can write down therefore A and B are not independent events. So this is the way you are going to solve these kind of questions. Hope you got this.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.